Hi students, welcome back to Smarter Everyday Over Learning. Dear students, we have been learning the classes from the chapter Organic Chemistry, some basic principles and techniques from grade 11 NCERT. Right, dear students, up to now about the qualitative analysis completed. Once you can check the description, I'll provide for you all the links in that. And now, yesterday's session also I have started the quantitative analysis, in that estimation of carbon and hydrogen, these two completed. And students, in yesterday's session only estimation of nitrogen, in that quantitative analysis about Duma's method is completed, including with that diagrammatic representation and the animated part also I explained to you. And now students, in this session you are going to learn about, in that estimation of nitrogen only, Kjeldahl's method I am going to explain with complete information of apparatus for estimation of nitrogen by this Kjeldahl method. And what is the example here, example also you need to know here in this session, and how we can calculate the total percentage of nitrogen in this estimation of nitrogen, Kjeldahl's method. Okay, this is, here you can see K is silent, the correct pronunciation is Kjeldahl's, H-A, this is L students. Okay, this is more convenient and simpler method for the estimation of nitrogen, and is largely used for the estimation of nitrogen in fertilizers. You can see here I have written fertilizers and foodstuffs and drugs, etc. This method is, however, not applicable to the compounds containing nitrogen in a ring. Specific ring, here I can draw the diagrams. Here this is a ring compound, here it contains nitrogen. This is known as pyridine. Okay, here also two rings and these are containing nitrogen again. This is known as quinoline. If suppose in these ring compounds nitrogen is presented, it is this is the method. This Kjeldahl method is not applicable to these type of compounds. And compounds containing nitrogens directly linked to the oxygen atom. For example, here the best example is NO2. Directly it is attached to that links, or another nitrogen atom that should be azo group. You know that the formula N double bond N. This is azo group. And this type of compounds, if nitrogen is presented, this is very easy to estimate the nitrogen, estimation of nitrogen by using this Kjeldahl method. Okay students, and the apparatus is used for the estimation of nitrogen. I'll explain you now. Students. Let's see the principle. What is the main principle involved in this Kjeldahl method? Here, a known mass of the organic compound is digested, nothing but heated, digested with concentrated H2SO4, concentrated sulfuric acid, in the presence of potassium sulfate, K2SO4, potassium sulfate, and a little amount of copper sulfate, CuSO4. Here students, these two you have to take in a Zelda flask. Okay, here copper sulfate is acting as a catalyst. That means it is not directly involving or directly participating in that chemical equation. It gives a support to that chemical equation to complete. This is the catalyst, CuSO4. And these are the solutions you have to take in a Kjeldahl flask. Just like this is the Kjeldahl flask. And students, here organic compound, here you can take the organic compound here. What is the organic compound? You have to estimate, but in this organic compound must has nitrogen, and in this organic compound, including with K2SO4. As I told you, K2SO4 and CuSO4. Here is the copper sulfate is acting as a catalyst here. And here you can place just like a small funnel. Through this small funnel you have to add this organic compound and K2SO4 solution and copper sulfate also. After completion of adding these solutions, and you have to add here just like a rubber cork, then the use of this is you have to avoid the bumping of these solutions to outside. Then if any fumes are formed here, then to avoid the escaping of these fumes through this Zelda flask also you need to avoid that. Zelda's flask. And student, this complete apparatus you need to fix to a stand. Here a stand you can take, and you need to fix this Zelda flask to a stand here with the help of wire gauge. Here with the help of wire gauge and with the help of tripod stand. This is a tripod stand. You need to place that Zelda flask on the flame of Bunsen burner. Okay students, and here the presence of potassium sulfate, here K2SO4 and little copper sulfate, or in the place of copper sulfate you need to take mercury also in a long necked flask. This is the long necked flask. This is known as Zelda flask, as I told you. And here potassium sulfate raises the boiling point of H2SO4. Potassium sulfate raises the boiling point of H2SO4 and thus ensures the complete reaction, while copper sulfate or mercury catalyzes the reaction. Here CuSO4 is acting as a catalyst. Okay, as a result of digestion or the heating process of the nitrogen present in this specific organic compound is quantitatively converted into ammonium sulfate, NH4 twice SO4. This is ammonium sulfate. Ammonium sulfate thus obtained is boiled with excess amount of NaOH. Again it is boiled with excess amount of NaOH solution to liberate here the ammonia gas NH3. To liberate ammonia gas, which is then absorbed in a known excess amount of standard sulfuric acid or hydrochloric acid. Okay students, here is the first Zelda flask. In this only, while we are heating the complete solution, the formation of ammonium sulfate takes place here. Formation of ammonium sulfate in this Zelda flask. After that, what we have to do, this complete Zeldalized solution, this is ammonium sulfate, we have to treat with NaOH solution. Then what you should get? Ammonia fumes. Now you can see clearly the chemical equations for this. Here the presence of nitrogen from the organic compound, it can be treated with concentrated H2SO4. Then concentrated H2SO4, these two are reacting with each other while heating process. While applying some heat, then NH4 twice SO4 should come. This is only ammonium sulfate. And students, to this ammonium sulfate, NH4 twice SO4 plus, if you treat with NaOH solution, here also you can apply some heat, then sodium sulfate Na2SO4 will come, including with water, and here is the major product, ammonia NH3. Okay, again the formed NH3, the formed ammonia fume should be treated with 2NH3 plus H2SO4. As I told you previously, here H2SO4 or HCl also no problem. Here the final product should be NH4 twice SO4. Here is the ammonium sulfate, right? And the volume of the acid left unused is found by the titration against the standard alkali solution. Here is the titration process you need to do. How I'll explain titration process against the standard alkali solution. Here is the alkali solution is NaOH, nothing but basic solution, aqueous basic solution. So here is the titration reaction in between this NaOH and acid H2SO4. So in these two titration reaction should be done. Then NaOH is the base here, and here H2SO4 is an acid, and when the base is reacting with an acid, obviously salt and water will form. This is according to the neutralization reaction or also acid base reactions. According to that only, here you can see the formation of sodium sulfate salt including with water. This is the final equation after completion of the titration against the standard alkali solution. From this, the volume of the acid used up or the volume of the ammonia which is evolved, and hence the percentage of nitrogen in the organic compound can be calculated. From this, the volume of the acid, nothing but H2SO4, and this is used up, or the volume of ammonia is evolved. These two percentages we have to calculate. Now students, here already the formed Na2SO4, how we can treat it with this H2SO4 diagrammatically, let's see. For this we have to take one volumetric flask. Here is the volumetric flask, and in this volumetric flask you have to take, starting what you have got here, NH4 twice SO4. This is only ammonium sulfate and also called as zeldalized solution, and plus NaOH. You have to take these two solutions inside this volumetric flask, and with the help of wire gauge you have to heat this also. Before going to heat this, you have to cover it with a rubber flask, just like rubber cork, okay, rubber cork. And here, just like delivery tube, you need to insert inside it with a bulb here, and just like this. Here is a bulb, and here you need to connect. This is Kjeldahl's trap. Here, just like condenser, one arrangement should be there, just like this, just like a condenser. Here is the end of this. One conical flask you need to take here, and here a known volume of standard acid. This volumetric flask is connected to a stand just for fixation, and with the help of wire gauge and tripod stand here, we have to heat it gently with a Bunsen burner. Here you have to take Bunsen burner, or instead of this you can take the spirit lamp also, no problem. Here is the Kjeldahl solution, that is ammonium sulfate plus NaOH you have to take inside this. This is the volumetric flask, and here is the rubber cork, okay, and here as a condenser, it is connected to tap sink, and it is connected to directly water or to tap. Here is the conical flask, and after heating process from this volumetric flask, to this Kjeldahl trap, NH3 plus steam forms in the form of fumes, and it is directly comes and here condenses. Then known volume of standard acid should be collected here. And now students, you can see as a result of the digestion, the nitrogen present in that specific organic compound is quantitatively converted into ammonium sulfate. Here, that is the digestion process or heating process, you can see in this diagram. Now after, here is the conversion of ammonium sulfate takes place, and after this diagram we have to see the formed ammonium sulfate is going to treat with NaOH. Here is the diagram, treating with NaOH, then NH3 fumes will come, NH3 fumes, and this NH3 is treating with again H2SO4. Now NH4 sulfate will form. Okay, now let's see the calculations. In this calculation, just let the mass of the organic substance we have taken, that should be W grams, and the volume of H2SO4 we have taken, that is V, capital V centimeter cube of M1 molarity. Now the volume of NaOH is used for the titration with excess amount of H2SO4. That should be small v centimeter cube of M1. This is also molarity. Applying the molarity equation, here the molarity equation is small nb capital MB VB is equal to NB MA VA. This is the molarity equation, where NB is equal to this, NB is equal to, and these are all NB, MB and VB are the acidity, molarity and volume. Acidity, molarity and volume of NaOH is used NaOH, while Na, Ma and Va are basicity and say molarity and volume of acid which we have used, H2SO4 acid. Okay, basing upon this molarity equation, 1 into small v into M1, that is molarity of NaOH, this is the alkali solution, is equal to Na means 2 into M1 into capital Va of H2SO4. Okay, or Va is equal to, capital Va is equal to small v by 2, basing upon, according to that basicity of H2SO4, sulfuric acid is equal to 2, basing upon this. Now the volume of H2SO4 used by NH3, here volume of H2SO4 which is used by NH3 ammonia, it should be calculated by capital V minus small v by 2 centimeter cube of molarity of H2SO4. But you know that capital V minus small v by 2 centimeter cube of H2SO4 is equal to 2 into small v by 2 centimeter cube of molarity of NH3 ammonia. Okay, why? Because 1 mole Basing upon this, 1 mole of H2SO4 neutralizes the 2 moles of NH3. Okay, here this you have to remember, 1 mole of H2SO4 is neutralizes 2 moles of NH3. Now 1000 centimeter cube of 1 mole of NH3. Will this solution contain NH3 is equal to 17 grams or N is equal to 14 grams. This also you need to remember, N is 14 grams. From 2 into capital V minus small v by 2 centimeter cube of M1 of NH3 will contain N is equal to 14 by 1000 into 2 capital V minus small v by 2 into M1 grams. This is the mass of nitrogen present in W grams of the substance. Now the percentage of nitrogen should be the formula 14 into M1 into 2 into capital V minus small v by 2 by 1000 into 100 by W. Okay, 100 by W. Now 14 means 1.4 you should take here into M1 into small v by 2 by W. Now the formula of percentage of nitrogen 1.4 into molarity of the taken acid into twice the volume of H2SO4 by mass of the substance what we have taken. And in general we can say that the formula percentage of nitrogen 1.4 into molarity of the acid into basicity of an acid into volume of an acid by mass of the entire substance what we have taken. Okay students, and if however the acid is used is monobasic acid, then the basicity should be 1. If it is monobasic in nature, the basicity is 1. Now this equation is reduces to 1.4 into molarity of an acid. Here basicity of an acid 1, then you can ignore this. Now molarity of an acid into volume of an acid by mass of the substance what you have taken. And also you can write this 1.4 into, in the place of molarity you should take normality also. No problem, normality of an acid into volume of acid, same volume of acid what we have taken, and by the mass of the substance taken. Okay, and for monobasic acids molarity is equal to normality only for monobasic acids. This you have to remember, right? And according to this you have to write this entire formula of calculation of percentage of nitrogen should be like this: 1.4 into normality of an acid into volume of an acid by mass of the substance what we have taken if basicity of an acid is 1. Right, now let's see one example of calculation of these percentage of nitrogen. Here you have the example. Let's see how we can calculate the percentage of nitrogen during the estimation of nitrogen present in the organic compound by Kjeldahl's method. The NH3, the ammonia, evolved from 0.5 grams of the compound, neutralized 10 ml of 1 mole of H2SO4. Then find the percentage of nitrogen in the compound. Here students, some values they have given. Now let's see volume of H2SO4, what we used. the used H2SO4 should be 10 ml of 1 mole of H2SO4. 10 ml of solution, that should be 1 mole. And now H2SO4. Now H2SO4 plus NH3. What you should get? Ammonium sulfate, you should get NH4 twice SO4. This is the chemical equation. And if you want to balance this, here if you place 2, that should be balanced. Now, therefore, basing upon this, you can say 10 ml of 1 mole of H2SO4 is equal to 20 ml of 1 mole of NH3. Okay, basing upon this equation, you can conclude that 10 ml of 1 mole of H2SO4 is equal to 20 ml of 1 mole of NH3. Now, 1000 ml of 1 mole of 1000 ml of 1 mole of ammonia is containing nitrogen amount is 14 grams. Therefore, for suppose 20 ml of 1 mole of ammonia NH3 will contain N is equal to 14 by 1000 into 20. Okay, but this amount of nitrogen is present in 0.5 grams of the organic compound, what they have given in the question itself. But this amount of nitrogen is present in 0.5 grams of organic compound. Now the percentage of nitrogen, if you want to calculate the percentage of nitrogen, 14 into 20 by 1000 into 100 by 0.5. Okay, now if you do this calculation, you should get 56. Alternatively, the percentage of M is equal to 1.4 into volume of acid we used into the basicity of an acid into molarity of the acid by the mass of the substance what we have taken. And from this, 1.4 into 10 is the volume of the acid, and basicity is 2 and molarity is 1, 0.5. And from this you should get simply 56. So this is the way of calculation during the estimation of nitrogen present in the organic compound by Kjeldahl's method. The NH3 is evolved from 0.5 grams of the organic compound neutralized with 10 ml of 1 mole of H2SO4. Now this is the percentage of nitrogen. This is the entire apparatus for estimation of nitrogen by Kjeldahl's method. Here you can see the starting Zelda Flask in that organic compound with concentrated H2SO4 and K2SO4 and CuSO4. Potassium sulfate, copper sulfate also we have to take in this. After heating, the process of heating, Kjeldahlized solution will come. This Kjeldahlized solution nothing but here Na4 twice SO4 ammonium sulfate. This ammonium sulfate you have to treat with NaOH. This is the volumetric flask. Again you have to take it in this volumetric flask, and here also with the help of Bunsen burner you need to heat them, and NH3 fumes will come, and this is the condenser, and this is Kjeldahl distillation process. Okay, and this is the complete apparatus. Now what are the equations are going on, we have discussed already. Okay, and now this apparatus, the complete activity, the animated part, let's see. Then you have to understand very easily, you can understand very clearly. Okay students, after that, just if you understand that this class and what is your view and opinion, you have to tell in the comment section. Now let's see the animated part of this Kjeldahl method. estimation of nitrogen by Kjeldahl's method. Here we have to take one Bunsen burner with the help of tripod stand and wire gauge with the help of one stand. We have to place one Zelda Flask on the flame, and that Zelda Flask containing the organic compound, which is coal. Here you have to take coal here, and copper sulfate you need to add to them. Here copper sulfate is acting as a catalyst of the reaction. And now NaOH solution. NaOH solution you need to add to that particular solution what you have taken in that specific Zelda Flask. After that, heat gently that complete solution what you have taken, and again we have to connect one condenser. Condenser is having water outlet and water inlet, and after heating process to this Kjeldahl trap, ammonia fumes will come, and this can condenses as ammonia solution. You can see in this picture what is the complete process while we are heating that complete organic compound. You can see here. Now this is the apparatus experiment. Okay students, this is about completely the information of Kjeldahl method, the animated activity part. Right, I hope you have understood and I hope you like this class. Okay students, thank you so much. This is about the estimation of nitrogen of an organic compound and basing upon the quantitative analysis. Right, thank you so much. If you like this video and if you understand this class, please subscribe and click the bell icon for my further updates. Thanks for watching.